Hello, I hope everyone is doing well, and that you also had a chance to look at the lessons, do the homework, and look at the solutions to L'Hopital's rule. If you have not been able to do that yet, please do so as soon as possible to get caught up. This next lesson is over derivatives of inverse functions. It's only one lesson, but the homework I'll give you guys a couple days to work on before I go over the solutions. So the idea here is we're going to generate another formula. Once we have the formula, then we will use it. And in order to understand how to come up with the formula, let's first revisit inverse functions. So take a moment to just think about how we form an inverse function graphically and algebraically. If you remember correctly, algebraically, we simply switch the x and the y values of our function, and then we end up solving for y. The notation we use is this right here. Looks like f to the negative 1 of x, but this is the inverse of f of x. We've seen it with inverse trig functions as well, that little negative 1 indicating it's the inverse of our function. Graphically, a function and its inverse will be symmetric with respect to the line y equals x, or reflect over the line y equals x. So I just want to practice real quick to review an example of how we algebraically find the inverse of a function. So let's go ahead and do so with f of x is equal to the quantity of x plus 3 squared. We want to find the inverse of f of x. Well, instead of using the f of x notation, let's just use y equals the quantity of x plus 3 squared. This is where I now want to switch x and y, and then continue to solve for y. So my next step is to take the square root, but remember when we do that, we want the plus or minus the square root of x, because if you think about this, f of x is quadratic. It's going to graph a parabola, and the inverse of a parabola that either opens up or down is a parabola that opens sideways. So we need the positive and negative square root to show us the top half of that sideways parabola and then the bottom half of that. So then we're going to get that it's equal to y plus 3. So just rearranging this, I'm going to subtract 3, but I'm going to put that first. So negative 3 and then plus or minus the square root of x. But now I want to rewrite this with the notation for the inverse of f of x is equal to negative 3 plus or minus radical x. So next, what I'd like for you guys to do is graph both the function and its inverse on your calculator. You might need to, what could be easier is just to enter this inverse as two separate equations, so that y would equal negative 3 plus radical x, and then y equals negative 3 minus radical x. But you could also go to menu 3, the graph entry edit, and actually if you go to number 2, I believe it'll have you type in a relation, and then you can type in this function exactly as it looks. So go ahead and pause the video, graph that, and then continue. So this is what you should be looking at. Again, I graphed it in as the positive and then the negative, but it's negative 3 plus radical x and then negative 3 minus radical x. What I also constructed here, which you don't have to do, some tangent lines. So if you just want to go ahead and look at this as I discuss these, this is just going to help us lead up to the formula that we're going to need. So I'm going to call the tangent line on the original function, I'm going to call that line P, and then line L is the tangent line I constructed on the inverse of the function. So what I'm going to do now, our goal again, let me just write this out, is to come up with a formula. And then this is the notation we write for the derivative of an inverse function. So here's a notation for the inverse of a function f, the little prime symbol here for the derivative. So we want to come up with a formula for this. So right now I'm going to go ahead and say let any ordered pair x, y be contained, and I'm going to do this on purpose, I'm picking the inverse. So I'm letting this, any point right now, x, y, be an element of, that's what that symbol means, on the inverse here, be an element of the inverse. And anytime I write this, so if x, y is contained on this inverse function, this means, if I write it in just function notation, that the inverse of f of x is going to equal y. And just to apply it to an example, if you notice here I have the point 4, negative 1. So if we say let 4, negative 1 be a point on our inverse function, then this implies that the inverse of f of 4 is going to equal negative 1. Then continuing this here, so if I let this happen for any point x, y, then the ordered pair yx, because I'm just going to switch around the x and y values, that's going to be a point on the original function f. And then to translate this back to interval or function notation here, I'm going to say, well, then f of y is going to equal x. And then continuing this with what's in blue, then this means that the point negative 1, 4 is contained on f, which implies that f of negative 1 is going to equal 4. And if you see this here, looking at this point, f of negative 1 is going to equal 4, and then down here the inverse of f of 4 is going to equal negative 1. So what I'm looking at here is let x, y be a point on the inverse, then we can write it in function notation this way, then the ordered pair yx is going to be a point on the original function, and we can write it as f of y is going to equal x. So next I'm going to go ahead and talk about the slopes. So the slope of line L, so this tangent line down here that I'm calling L, is 0.25 or 1/4. If I go to the slope of the tangent line P, my slope is 4. So I have a 1/4 and a 4, which are reciprocals. So the slope of line L is equal to the reciprocal of the slope of line P. Now we're going to use that to rewrite the notation here, so we're no longer using slope of line L and slope of line P. So off to the side here, I'm going to say, well, the slope of line L, because it's a tangent line, is the slope of the tangent line, so it's the derivative. And line L is on the inverse, so it's the derivative of the inverse. So I could write it like this. Here's our inverse, and then here's the derivative of the inverse of f of x. And then the slope of line P is the slope of this tangent line here, or it's the derivative. So it is the derivative, not of f of x, because we switched around the points. So all points on the function here are labeled yx. So it is actually the derivative. It's f prime of y instead of f prime of x. So next what I'm going to do is just go ahead and replace this. So if the slope of line L is equal to the inverse, the derivative of the inverse of f of x, that's what I'm going to use here, which is what I have up here. So that's the start of our formula. That's going to equal the reciprocal of the slope of line P, which is f prime of y. So essentially this is our formula. I just don't want to leave a y in there. So what this becomes now is the derivative of our inverse of f of x is equal to 1 over f prime. Now if we go back up to the very top here, I want to replace y with something. Well, up here y is equal to the inverse of f of x. So that's what's going to go in here, the inverse of f of x. And it looks a little overwhelming at first, but this is our formula that we're going to use. So this is the derivative of an inverse function. So there's our formula. Now the examples we're going to go through and use, we could just use this formula here, but there's going to be some side work we have to do. This is coming from a gift that I will have scanned in as and posted as a separate PDF. So let's go ahead and take a look at a few examples. All right, here I'm giving you, instead of f of x, it's g of x is equal to x to the fifth plus 3x minus 2. Again, this notation here, g to the negative first, is going to denote the inverse of g. Then the derivative, so I'm looking right here, the derivative of the inverse of g of 2 is equal to what? So our first step is to just write out the formula, but here we're going to use g of x instead of f of x. So the derivative of my inverse of g of x is going to equal 1 over g prime of the inverse of g of x. So that's the notation. I'm just replacing the f's with g's. But now I want to find this at a specific x value. So then I'm going to rewrite this as the derivative of the inverse of g of 2 is going to equal 1 over g prime of the inverse of g of 2. So I just simply replaced all my x's with 2. But now I need to figure something out. So I need to start right here. I need to know what that is before I do anything else. So my second step is to go ahead and figure out what the inverse of g of 2 is. So right now I have no idea what this is. I can't use my g of x function just yet, but I will be using it. We have to do some rewriting here. So what we're going to do is let's pick an ordered pair. So I'm going to say let's let 2 comma u be a point on the inverse of g. Then if I switch this around, u comma 2 would be contained on the function g. Now I can go back up and use this. So this allows me to say then that g, so we'll say therefore g of u is going to equal 2. Well, I have g of x up here. G of u is just going to become u to the 5th plus 3u minus 2. So now I could set that equal to 2. So I'm going to go ahead and write that underneath. So then g of u, which again is u to the 5th, plus 3u minus 2 is going to equal 2. Now with these, it's going to be a simple guess and check. These values for all the problems I'm going to be giving you should be simple values if we can't solve by factoring or any other way. So what I'm going to do here, just kind of pick a value. We could even say that maybe u to the 5th plus 3u is going to equal 0. I'm sorry, 4. Adding 2. And that might be a little bit better to sort of guess and check. We might try a 0, we might try a -1, we might try a 1, a 2, a -2, and in this case actually looking at 1. 1 to the 5th is 1 plus 3, so this is true when u is equal to 1. So now what we're going to say is that the inverse of g of 2 is going to equal u. And going back up to the top, if I let 2 comma u be on the inverse here, we could also say that the inverse of g of 2 is going to equal u. So that's where I'm using this down here. And we said u is equal to 1. So we have the inverse of g of 2 is equal to 1. So now when I come back over to this step, this whole quantity here gets replaced with a 1. And as soon as we do that, it becomes a lot easier. So now what I need to do next is figure out what g prime of 1 is. So our third step is to say, well, g prime of 1 is equal to what? Well, if we go back up to g of x, we just need to find its derivative. So if g of x is equal to x to the 5th plus 3x minus 2, its derivative is 5x to the 4th plus 3. And then its derivative evaluated at x equals 1 is 5 times 1 to the 4th plus 3, which will give us 8. So now we go back up here, and this becomes 1/8. And we're looking at that answer here as B. So there's 2 side steps we need to do. Obviously, the more complicated one is this second step here, because we have to sort of come up with generic points to help us rewrite this, and then we go back and we use the function. So a couple different ways you're going to see with these examples. When we're given a function like this, and then we're asked to find a specific value here for the derivative of the inverse, this requires the most work. Other ways our problems will be presented to us is going to be a lot easier. So let's try another one like this. All right, here we're going to let f of x equal 3x to the 4th plus x. And notice here it's saying let g be the inverse. Instead of f to the -1, it's just calling it a completely different function, which sometimes it does. So we're going to make it a little bit easier for us. Instead of it being g, we're going to let g be this notation, because in our formula that's going to be very helpful. So if g of x is equal to the inverse of f of x, then g of 2 is going to equal, g prime of 2, which is what we're asking for here, is going to equal the derivative of the inverse of f of x. So that's just rewriting it to get it out of terms of g of x and into terms of f of x. So really this becomes of 2. Let's put that in there. All right, so our first step, we're going to say that the derivative of the inverse of 2 is going to become 1 over f prime of the inverse of f of 2. So like our last problem, we need to first figure out what the inverse of f of 2 is. So our second step off to the side here is we're going to let the inverse of f of 2 equal u. We'll write it that way first. Then we know that the point 2u, just like the last one, is contained on our inverse function. And then the point u2 is contained on our function f of x. So then we can write it this way. Therefore, f of u is equal to 2. Now we can use f of x. So again, f of u is going to equal 3u to the fourth plus u. So then we're going to set 3u to the fourth plus u equal to 2. Now try this. We know if we substituted in a 1, we're not going to get a positive 2. We need to go down, decrease it from the 3, so maybe a negative 1 would work. So if u is equal to a negative 1, we would get 3 times negative 1 to the fourth plus a negative 1, and that actually will equal a 2. So this happens when u is equal to negative 1. So now what I can do is go back over to my first step now and write this as 1 over f prime of negative 1. And then step 3 is to figure out what f prime of negative 1 is. So again, f of x is equal to 3x to the fourth plus x. F prime of x is equal to 12x cubed plus 1. And then f prime of negative 1 is equal to 12 times negative 1 cubed, which will give us a negative 12 plus 1, which is negative 11. So my final answer here becomes 1 over negative 11. So that's also B. All right, so when we're given problems like 1 and 7, these are the 3 steps we want to follow. First, we write it out, and then once we have a value here, we go to our second step. You can see maybe now it was a little bit quicker or more efficient to write this out here, but we let whatever we're trying to find here equal a u. Then we go back to the ordered pair format and switch it around, and then that allows us to figure out what our function could equal at that u value. We set our function equal to that. That helps us determine u. Then we can go back and substitute it in right here. And then our third step is to find the derivative and evaluate it at that x or the u value that we're looking at. All right, so let's take a look at another example. All right, if you notice here, we're not given a function, so this is actually a little bit easier. We're given straightforward or directly the values here that we're looking at. So if we go to what we're asked to find here, again, our first step is to figure out what the derivative of the inverse of f of 5 is. So we know this becomes 1 over f prime of the inverse of f of 5. So our second step is to figure out what this is. So step 2, we want the inverse of f of 5. Well, right now, I'm going to go ahead and still let that equal u. We're going to go through the same steps. So then, again, this means that 5u is contained on our inverse function, and then u5 is contained on f. And then what this means is that f of u is equal to 5. So we're able to come up with this ordered pair, and that leads us to write that function notation. Well, if we go back up to what we're given, we're only given 2 more facts here. F of 4 is equal to 5, and that helps us fill in the blanks. So f of 4 is equal to 5, therefore u equals 4. So a little bit different approach to help us find u. So now I go back to my first step. This now becomes 1 over f prime of 4. And then step 3 is to find out what f prime of 4 is. Well, that's our other fact that we're given. F prime of 4 is equal to 2/3. So now going back to our first step, this becomes 1 over 2/3, which is really the reciprocal. We could think of multiplying by 3/2 and 3/2 here, or it's just a reciprocal of 2/3. So we actually get 3/2 as our answer. So option D. All right, let's go ahead and try one more. looking at number 9, we're actually given a table, which let me go ahead and draw. Okay, so for number 9, we're given this table here, and we are asked to find the directions here. It says if h of x is equal to the inverse of f of x, then h prime of 3 is equal to what? So again, we're going to start with just this statement again. Well, if h of x is equal to the inverse of f of x, then h prime of 3 is going to equal the derivative of the inverse of f of 3. And then we know this is going to equal 1 over f prime of the inverse of f of 3. So that's our step 1. Step 2, I'm actually going to take a look at down here. So this is our first step. Our second step, again, I want to determine what is the inverse of f of 3. So right now I'm going to let that equal u, which means that the ordered pair 3u is on our inverse. Switch this around, u3 is on our function. And then this means that f of u is equal to 3. So if I go up to my table now versus our last example where we were just given the answers directly or the values directly, here we have to go find it from the table. So I have to be very careful. We need f of x to equal a 3, and that happens right here. That f of 2 is equal to 3. So u is going to equal 2. So now I go back up to my first step here. This becomes 1 over f prime of 2. So my third step now is to figure out what f prime of 2 is. So f prime of 2, if I go to my table, f prime of 2, I'm looking right here, f prime of 2 is going to equal 1. So now this becomes 1 over 1, or just 1. And this was also multiple choice. I didn't write those out, but when you go to look at the sheet, it's actually choice E. Now, they did give us some extra information. We did not need the G or the G prime whatsoever here. All right, so a little bit different with this homework assignment. Like I said, this will be posted as a separate PDF, but I want you guys to finish the derivatives of inverse functions gift. And then I want you to, I'll post this as an assignment. I want you just to send me a picture of the work completed. I'm going to count this as a homework grade, but you're going to have a couple days to do this. So all of this should be turned in before I show you the homework problems. But please, along the way, if you guys have any questions whatsoever, let me know. I did one of every example you'll see, so hopefully that will help. But like I said, let me know if you have any questions. I'll be happy to go over those examples with you as you have questions. If not, then like I said, I'll just count this not as a correction grade, but just as a completion grade, and then make sure when I do post the homework answers that you take a look at those.